determining the number of all subatomic particles. In this example problem, it says Cu2+, or copper 2 positive, has a mass number of 64. And we have to figure out the number of protons, neutrons, and electrons. So let's figure out the easiest one first, the number of protons. If we know the element, all we have to do is go to our periodic table and check and see what the atomic number is. And I can see that the Cu has an atomic number of 29, so that must mean it has 29 protons. Now they gave us the mass number, which is 64, so all I have to do is 64 minus 29, so mass number minus atomic number, to just get the neutrons, because mass number is the atomic number or number of protons plus neutrons. So I have to subtract the atomic number. And when I subtract 64 minus 29, I get 35. And so I know that the number of neutrons is 35. Now, to figure out the number of electrons, because this is an ion, we have to remember that it's positive, so it's a cation, and it has lost electrons. So it's lost the regular number of electrons that we usually have. So Cu2+. What this means is that we have to remember that the atomic number in a neutral atom equals the number of electrons. So when Cu is neutral, it has 29 electrons. But as this ion is showing us, it lost 2 electrons. Why? Because it has a 2+ charge. So that's telling me it lost 2 electrons. And that means 2 protons are able to shine out and put a 2+ charge on it. So I'm going to subtract 2 electrons. And when I subtract 2 electrons, I get 27 electrons. And so what I'm going to write up here is 27. And now I've figured out the number of protons, neutrons, and electrons.